All right, in this video, I wanted to give a little historical context to the thermal physics we've been doing and tell you about an important experiment. So the state of our knowledge of heat and energy in the 17 to mid 1800s partly is consistent with what we've done so far in this class. So in terms of work, people knew about kinetic and potential energy and how to, do work on objects with forces. This had pretty much, that what we call Newtonian mechanics had pretty much been worked out. And, energy is sometimes conserved, sometimes it's not. And there wasn't a good big picture understanding of where the energy went, I guess. At the same time, there also was this picture of how objects changed temperature. And the idea there was, objects change temperature. If you have two objects and they're at different temperatures, you put them next to each other, one heats up, the other one cools off. This must be because something flowed between them. And they said that this was some invisible fluid called the caloric, from the, root calor meaning heat. So this caloric fluid would move between objects and change their temperatures, and presumably it would be, this caloric fluid was released by fire and, things like that. We can kind of imagine some primitive picture like that. Anyway, and that picture of the caloric is historically what led to the use of these units of calories for heat energy. And we haven't really talked about calories. We're not really going to need to use them, but you hear calories used, and that's, they are a unit of energy as we now know, but they originally started as a unit of heat, which was considered this separate thing. Okay, so in the mid 1800s, James Prescott Joule, a name who should look familiar now, showed the equivalence of work and heat. And he did it like this. So they know from the caloric model of heat that if you have some container of water and you put some hot piece of metal in it or put it on some fire of some known composition or something, you can increase the temperature of this water in a controlled way. So you can start with water at 20 degrees C and you do this known process to it and you increase its temperature to 30 degrees C or 100 degrees C or whatever. Okay, so what Joule showed was that you can do the exact same thing. You can end up with the exact same water at the exact same temperature with a process that involved no heat, nothing hot, no caloric, that looked like this. So you have we'll draw a little thermometer in there to remind us that he's measuring the temperature of the water. So he did something like this. This is the cartoon version, of course. He had some little paddle, rotating paddle wheel thing in here. And he had this hooked up to some kind of pulley system where he could attach weights to this and let these weights fall. And in the process, they are decreasing their potential energy and pulling on this rope, and the rope is spinning this paddle. They're doing some amount of work. So this object is losing potential energy, doing work on the paddle. The paddle is turning in the liquid, and because of the non-conservative viscous force of this fluid, the viscosity of the water, some of that energy goes into stirring the water, but some of it disappears in terms of mechanical energy. Some of it turns into thermal energy and increases the temperature of the water. So Joule showed that this meant that you could do a known amount of work on the water, increase its temperature by some amount, just the same as if you had lit a fire underneath it, and therefore you could figure out how many joules of work were equivalent to however many calories that took to increase the temperature of the water. So anyway, that was this big connection. And of course, this was needed because, we know that the thermal energy of this water, if it's at some temperature, that is the kinetic energy of all of the molecules of water moving around, but they had no way to see that. They can't measure that kinetic energy directly. So that, that's obscured from their observations. You have to do something like this. So I think this is really a neat experiment. It's, of historical importance and led to the real, connection of this idea of work and heat. And, that's a big part of the field of study that we call thermodynamics, which is super important. So anyway, yeah, historically important experiment by James Prescott Joule.